Good day, young scientists, grade 9s, boys and girls. All right, I'm going to deal with assignment number 11. We're going to look at the memo, or that's the memorandum of the solutions or answers for assignment number 11. Now, the title or the topic for this assignment is forces and electrical cells, which means everything that we are going to deal with is all about electrical cells and forces. Then the number of the total marks is 15, time is 20 minutes. So whenever you are dealing with an assignment, or whenever you are answering questions in an assignment form, or as an example cycle test, try a little best to make sure that you do the work within the given time. This is your time to practice, to work within a given time. Otherwise, if you fail to do so, you may find it very difficult to finish up an exam. And at the end of the day, you lose a lot of marks, right? So try your level best to always practice to work within a given time. So this work was just supposed to be done within 20 minutes, right? Before you start answering questions, make sure that you go through the instructions. Instructions, guidance instructions are very, very important. Failure to follow the instructions simply means you're going to lose a lot of marks. So make sure that you follow the instructions. It's very, very important. So you are supposed to write the work in your NS book, and you're supposed to write your full name, your class, your full date, assignment number, and topic. Yes, I mean your full name and your class. Yes, it is your book, but you're supposed to write your full name at the top so that when you submit your script, right, on Google Classroom, we can easily identify you, right? It's very, very important. Otherwise, we may not even know who you are if your name is not in, right? We cannot just make use of your email address, right? Because your email address might not show the name. So in that case, it becomes difficult for us to identify your script and to identify you as our learner or not, right? So make sure that that is done. Then circle the correct letter from the given options. So you're supposed to circle it, right? That's what you're supposed to do. That's how you're supposed to write your answers, right? Then you must make sure that you write legibly and then submit it on Google, grade 9 NS Google Classroom. Right, on grade 9 Google Classroom, if you submit your work on grade 9 Google Classroom, it's going to be very easy. We'll be having your history there. All the papers will be shown. That's the papers that you were assigned to do, and all the work that you submitted is also captured there and is stored there under history part, right? So if you fail to submit your script on Google Classroom, then we may not be able to see whether you did the work or not, right? So in order for us to see and yourself as well to know that the work is in, it must be submitted on Google Classroom because it captures everything and everything will be shown and is kept there, right? So please try a level best to submit it. Yes, there are some technical issues. Some of you, I think it was because of poor network in the area that you were in, or maybe you didn't have data. So at the end of the day, you encountered some challenges there in submitting your assignment. So please be patient and try and do submit your work in time so that if there are challenges, you'll be submitting your assignment within the specified time, right? So try and do your assignment early so that if there are some challenges when it comes to submission, you won't be disadvantaging yourself, right? Now, so instructions are very, very important. Now, I'm going to go through the questions, then I'll be explaining some items here and there. Now, whenever you are dealing with questions, especially multiple choice questions, please, even if it is not multiple choice, please take note of the keywords. Keywords are very, very, very important. They guide us, they direct us to identify the correct answer, right? So it's very, very important for you to make sure that you follow the instructions. Identify the key words in the statement or in the question or in the instruction, right? Now, let us look at number one now. Number one says there, which of the following factors does not affect the resistance of an electrical conductor? Now, if you check, there are four options, A to D, and A to D are capital letters, right? If you write a small letter as an option or a correct option, you're going to be marked wrong, or you lose a mark there because the options are capital letters. It's very, very important to make sure that you write the symbol the way it is written, right? If the symbol is not the correct symbol, then it means you're going to be marked wrong. In NS, we use a lot of symbols to represent something. So make sure that you write those symbols correctly. Otherwise, you lose marks. So in this case, our options are capital letter A, B, C, or D. Now, so from question one, which one is the keyword? The keyword in number one is like we are looking at what? We are looking at factors. We are looking at factors. These are the factors that affect resistance. The resistance that we are dealing with is electrical resistance, right? So from the list or from the options, we have got thickness, which is a factor, length is a factor, current was not mentioned as a factor when we talked about factors affecting resistance. Then type of material, yes, under resistivity, right? So there are three factors that are mentioned here, and the fourth one is current, which is not a factor. So which of the following factors does not affect? Does not affect, which means the one that does not affect resistance, it's what? It's current, which is C. Then we move on to number two. The name of the charge. So in this case, we are looking at what? A charge, right? That is moving to produce conventional electricity, right? So we are looking at a charge that is moving and it produces conventional electricity. Now, when you're talking about conventional electricity, what is it? That's electricity produced by charges which are flowing, and these charges are what? Are positive, right? So if you check on the answers here, electron, no, electron is not a positive charge. Proton, yes, this is the positive charge, right? That is in an atom. So if positive charges are moving, they produce conventional electricity. But before I identify this as in my answer, let me check what is written there. We've got atom. Atom, no, right? Atoms are not going to move to produce electricity. It's only the charge which moves and produces what? Electricity, right? Neutrons. Neutron, this is a neutral charge inside an atom. Now, so it means out of all these four options, conventional electricity is produced by a positive charge which is moving, which is what? B, right? Remember, atoms can only vibrate. We generally refer to them as what? Atoms, and as a particle. And it is made up of what? Electrons, protons, and neutrons. So the electron orbit around nucleus of an atom, where the nucleus is formed by what? Proton and neutron. So if the proton is in motion and is moving along a conductor, it produces what we call conventional electricity. That's 2B. Then we move on to number 3. The material, number 3, the material which conduct electricity. So we are looking at material which conduct electricity, right? Now, the material that conduct electricity, right? We have A, insulator. Insulator is a material that does not conduct electricity, which means A is out. Because an insulator is a material that does not conduct what? Electricity. Then B, we've got copper. Copper conducts conduct electricity. Copper is a material that conducts electricity. But before I say it's copper, let me see what I have there. There is iron. Iron is also an electric, is also a conductor. All right. So I have two answers here, right? Since there are two answers, let me check the fourth one. It's conductor, right? So these three are correct, right? They all conduct what? Electricity. But let me go back to the statement, right? A material which conduct electricity. Now, in this case, the material, we are not looking for a specific material, but we are looking for what? Anything that can conduct what? Electricity, right? So, if you check, we've got B, which is a specific material. C is a specific material, right? They conduct electricity. But according to this statement, it's a material which conduct electricity is known as, right? So we're just looking at any material. It's not specified, right? Which means our best answer in this case becomes what? D. Because when we are looking at D, D also cover what? Iron. It cover what? Copper. It cover what? Aluminium, right? So all those metals that can conduct electricity are referred as what? An electric conductor. All right. So in this case, it means our best answer is 3D, because we are looking for a material which conduct electricity, right? In other words, we are looking for a material that can just conduct what? Electricity. What is the other name for that? All right. So which means it's 3 what? D. That's the material which conduct electricity is known as. All right. Then number 4. Below is an electrical circuit. All right. Then, which means you must know the circuit components. The name of circuit components labeled P, Q, and T are. Now, so before I look at the options, I can first of all try and identify the components here. Now, the first component, P, cell, Q, switch, T, electric bulb, all right? Some refer to it as what? An electric lamp, right? Fine. Then let's check now. The name of circuit components labeled P, Q, and T are, then we have got cell, that's P, that's correct. Switch, that's correct. Wheel, it's not a wheel, which means A is out because of the last component, which is wrong. Then B, cell, switch, bulb. This B is correct. Let's check C. Battery. P is not battery because we are not looking at cells that are connected in series. So it's not a battery. D is also out. Why? Because it starts with what? Battery, of which P is not battery. Right? So C and D are out. A is also out. Then we have got B, which is having the correct components. Cell, switch, bulb. Right? So it means B is our correct what? Option. So please, it's not just a matter of just choosing an answer without reasoning, right? You must make sure that you reason, think, and reason. It's very, very important to identify the correct answer or the correct option. Then, number 5, what type of force acts between an object and the earth, right? So we are looking at what? Forces. Forces between what? Object and what? Earth. Remember, Earth is a planet. So whenever we are looking at planets, we are looking at what? Gravitational force, right? So which then means then that the force that we are looking for is gravitational, or it's a force that has to do with what? Earth, right? So in this case, it's gravitational. Now, if you check on A, magnetic force, we don't have magnets here. So we are not dealing with magnets. So A is out. Then B, friction. Surfaces are not rubbing against each other. So B is out. Then electrostatic. If we are dealing with electrostatic force, we are dealing with what? Charged particles or charged objects. So in this case, we are dealing with Earth, which produces gravitational, right? Then we have got D, which is gravitational what? Force. That's the correct one, right? So all these other ones have been eliminated because of what is happening in what we have in the question or in the statement, right? Then number six, field forces, which means our key word or key parts in the statement is field forces. Field forces are also known as, right? Now, if you check A, tension is contact force. It's not under field forces, so which means it's out. Gravitational force, yes, it's a kind of a force that falls under field forces. But is it our correct answer? Let's find out. We are looking for the other name here for field forces, of which gravitational is a specific type of force under field forces, right? We are in need of the other name for field forces. C, non-contact forces. This one is correct. Then let's check D before we finally identify the answer. D, contact forces. Field forces are not contact forces, so D is out. So which means, according to what we have seen, tension falls under contact force, which is out. Gravitational is a specific example of field forces. Here we want another name for field forces, which is what? C, non-contact forces. Remember, field forces are known as non-contact forces because objects are not in contact, or this object that experience this force are not in contact, all right? So that's non-contact forces. Okay, number 7. On number 7, we are looking at what? We are looking at, we are looking at objects M and N. Sorry. Right, we are looking at objects M and N. And here in the statement, we are told here that M and N represents a negative charge, which means M is negatively charged, N is also negatively charged. Then it says here, so it means we are looking at what? We are looking at like charges. We are talking about like charges because they are all having a negative charge. So it's like charges. Then what do we know about charges? Right, normally we say like charges repel, unlike charges attract. Right, if you still remember. Now, which statement best describes what happens between them, right? Now, so since they are like charges, it means they repel and repel, right? They repel, which means, according to A, repel each other, which is correct because they are like charges. Exert a force, what kind of force, right? When objects are repelling each other, the type of force is what? Repulsion. So this is correct. If you check B, it's repel, that's fine. Attraction, this is now wrong, right? So which means B is out. Then C, attract, no, like charges repel. So which means C is out because of attract. D is also out because it's attract, right? So it then means then that our correct answer is what? They repel each other and the force is what? Attraction. Sorry, they repel each other and the force is repulsion, right? That's our correct answer there. Then we move on to the next answer, to the next question. So it's 7A. 8. The unit of force, here we are looking at what? Unit of what? Force. So the unit of force, what is the unit of force? Now, ampere, this is what? For current, right? The charges that are passing a point in a given second, that's ampere, which is current. Volts is for voltage, that's the PD across a cell or a resistor. So this one is for voltage, it's not force. Kilograms is for mass, right? So it doesn't, it's not a unit for force. Then Newton, that's this one, which is the correct one. So it's what? Newton. That's the correct unit of force. Newton, from Isaac Newton, the first scientist to talk about force. Right. Then 9. What is the energy changes? So the keyword we are dealing with what? Energy changes. That takes place when an electric bulb is switched what? On. Right? So we are dealing with an electric bulb which is switched on. Right? So an electric bulb is connected onto what? Electric wires or connectors. Right? So electric bulb is connected onto connectors. Now, let's check. What are the changes? Chemical potential energy. In the statement, we are not informed or we are not told of the source of electricity, right? And again, this light bulb, right? It's an electric light bulb which is switched on, right? So which simply means then that we are not looking at the source of electricity. It could be connected, yes, to a cell, or it could be connected onto the mains for AC, right? Alternating current, right? So in this case, we are not told, we are not informed whether it is directly connected onto what? Onto cell. Let's check again, right? But what we know is electric light bulb produces what? Light. And some of the electric bulbs produces a lot of heat, and some, especially the ones that are made these years, they produce very little amount of heat energy, right? Let's check. Then here, it's electrical energy to light and heat, right? Right. Then kinetic, no, we cannot see, there's nothing that is going to move, or there's nothing that we are going to see moving, right here. So C is out. Kinetic energy is also out. Then going back to A and B, right? Here we're just looking at the electrical light bulb. It's switched on. So the best answer for this question number 9 is electrical, because it simply converts electrical energy to heat and light energy, right? So which means B is what? Out. Sorry, B is what? Our correct answer. We are regarding A as a wrong answer. Why? Because the bulb does not convert chemical potential energy, right, to light and heat. No, it converts electricity to what? Light and what? Heat energy. So it's electrical energy to light and heat. That's the correct answer. Then 10. Which of the statement best describes gravity? So we are looking at what? Force of what? Gravity here. We're looking at force of gravity here. That's gravity. Now, the shorter the distance, so it means we're dealing with distance here. The shorter the distance between objects, the stronger the force. Yes, this is true. If distance is short, the force of gravity will be what? Higher, right? Then B, the shorter the distance between objects, the weaker, then this is now wrong, right? If objects are nearer each other, it means there's going to be strong force that is going to be experienced by those objects, right? So B is out. The longer the distance between objects, the stronger the force. No, if objects are far away from each other, they may not even feel the force, right? So C is out, right? Distance between objects do not affect force. No, distance affect force of gravity. So D is out, right? So it means we have A being our answer. The shorter the distance between objects, the stronger the force of gravity, right? This is the correct what? Option. Remember planets, right? If they are far away from each other, it means the effect of sorry, it means the force of gravity that they are going to exert onto each other is going to be very, very small if they are far away from each other. But if they are nearer to each other, then the force of gravity will be very what? High. Right? Number 11. Which materials are non-magnetic materials? Right? Non-magnetic materials are materials that do not that cannot be attracted or that cannot be repelled by a magnet. Right? So non-magnetic materials are materials which cannot be pulled or pushed by a magnet. Right? So check on A. A, iron. Iron is magnetic, which means A is out because iron is magnetic. Then B, paper and plastic. Paper and plastic, these ones are non-magnetic, right? They cannot be pushed nor pulled by a magnet. Then, but let's check C. C, plastic and steel. Steel is magnetic, so C is out. D, steel and iron. Both materials are magnetic, which means D is out. So non-magnetic materials are, that's paper and plastic. These are correct what? Answers. Number 12. Kenzile board mass on a bathroom scale is 62 kgs. If gravitational acceleration is 9.81 meters per square second, how much is his weight, right? Remember, weight in this case is force, right? Which means we have to find the force. And we are given this statement, F is equals to mg. This is the formula that we can use to calculate what? Gravitational force, right? So in this case, we are going to say force is equals to mass of the object multiplied by gravitational acceleration, right? That's the force. Then from there, I'm going to substitute mass. Mass is 62 kgs. Then we multiply by 9.81 meters per square second, right? Then, since we are to multiply by 62 by what? 9.82, we are going to make use of our calculator, right? In this case, you find out then that, sorry, just a minute, just have to write the square here, it's per square second. Right? It's per square second, sorry for the per square second there, which is not all that good. Right, so it's 62 kgs multiplied by 9.81 per square second. So if you use your calculator there, you'll find out that it is going to be, sorry, using a calculator, we are going to come up with what? 62 multiplied by 9.81. You come up with 608.22. Then kgs, meters per square second is the same as what? Newton, right? So when you multiply, you get that, which means our answer is what? It's, in this case, it is D. That's our correct answer. Right, then we move on to the next one. Number 13. Right, number 13, it says then, the following are forces. The following are forces. So we are looking at forces here, right? Then the forces is magnetic force, tension. Magnetic is from magnet. Tension, when one end or both ends are pulled away from each other, that's tension. Electrostatic, charged particles produce electrostatics. Gravitational force, That's a planet and an object, or planets, right? They produce gravitational force. Then it says which one is the odd one out. Which one is the odd one out? Which means which one does not belong to the group of forces that we have here, right? Now let's check. By looking at forces, there are two groups of forces, right? That's field and contact. Let's find out. Do they all belong to one group or one class of forces? This is magnetic, it's field force. Tension is contact. Electrostatic, field forces. Gravitational, field forces. So we can then say tension is out of order because it is the only kind of force which does not belong to uh, field forces, right? So which means we can say tension. But before we say finally says tension, let's check. Magnetic force. Magnetic force, it can either be a push or a pull, right? Tension, it's only a push. Electrostatic, it's either a push or a pull, both forces. Gravitational, it's only a pull, right? So magnetic and electrostatics is both push or pull. Then tension, it's only push. Gravitational, it's pull. Push and pull are not the same, right? But these two, magnetic and electrostatic, they are fine. So which simply means we cannot say tension and gravitational are the odd ones out. Here we want one. Which one is the odd one out, right? So we cannot select an odd one by looking at the type of force that they exert on other objects, right? So it means the best option here is just for us to simply say tension is the correct, is our correct word, is our odd one out. Why? Because it's the only force that falls under contact. Whereas magnetic, electrostatic, and gravitational forces, they fall under field forces. So it means stating our answer here is what? B. This is the odd one out. This is the only force that falls under contact forces. The rest are field forces. 14. Which of the following statement best describes the effect of temperature? So we are looking at what? Effect of temperature on electrical resistance. This is my keyword. How does temperature affect resistance? Generally, before we look at the answers, we know that the higher the temperature, the higher the resistance. Why? Because when a material is heated, right, the particles are going to vibrate faster and faster, thereby hindering what? The charges that are moving. So in other words, there is a high chances of collision between the charges that are moving and the particles that are vibrating, thereby causing the resistance to be very high, right? So we are just saying the higher the temperature, the higher the resistance, or the lower the temperature, the lower the resistance, right? Let's now check. A, high temperature, it's a higher temperature, a higher electrical resistance. This is correct. Check number 2, or part B, or sorry, option B. High temperature, low electrical resistance. This one is out, right? High temperature, high resistance, but here it's low, which is wrong. Then low temperature, high electrical resistance. High here is wrong because the temperature is what? Low. Low temperature, low resistance. So this one is out because it says high here, whilst the temperature is low. So it's wrong. C is out. D, temperature does not affect electrical resistance, which is wrong. Temperature affects electrical resistance. So D is out. So the best option here is what? A. High temperature, high electrical resistance. Then number 15. The unit of electrical resistance is A, amperes. Amperes, this is the amount of charges that are passing a point per given what? Second, or in a second. So we find out that this is the amp. It's not electrical resistance. So A is out. Ohms. Ohms, this is the unit for resistance. And the symbol for ohms is omega, a Greek letter, it's omega. So this is the correct what? Electrical resistance. But let's check. C, volts. Volts, this is the unit for voltage. That is the PD across a source of electricity or across a resistor. So this is not a unit for resistance. This is the unit for voltage or for PD. That's the potential difference across a cell or across a battery or across a resistor, right? So which means C is out. Newton. Newton is the unit for force. It's not electrical resistance, so D is out, which means our only answer is 15 watt B, right? So, boys and girls, it's very, very important to make sure that whenever you are answering multiple choice questions, look at all the options, identify the best answer or the best option for a given statement. Don't be too quick to just identify an answer without thinking, without reasoning. It's very, very important. Look at all the options, identify the best option. Now, thank you so much, boys and girls. But may you also prepare for the next assignment. That will be assignment number 12. I'll give you information as we go. I wish you the best in your preparation and in your studies. Have a good day.